Lesson 5, Part 3, Scientific Notation. In many fields of science, we encounter very large or very small numbers. Scientific notation is a convenient shorthand for expressing these types of numbers. A positive number is written in scientific notation if it is written as the product of a number A, where A is greater than or equal to 1, but less than 10, and an integer power r of 10. Scientific notation takes on this form here. Some factor A times a power of 10. And the exponent can be a positive number or a negative number. Remember this? I know you've seen it like 3 times now. If the number being multiplied by a power of 10 has a positive exponent, you're talking really large numbers. If the exponent on your power of 10 has a negative exponent, you're talking really small numbers. So fields like microbiology would deal with these really small numbers. Exponents on powers of 10 that are negative, and maybe astronomy, astrology, are dealing with these large numbers. So their exponent on their powers of 10 are going to be positive. Positive exponents on your power of 10 equal large numbers. Negative exponents on your powers of 10 equal small numbers, meaning decimals. Okay, here's our powers of 10. And in standard notation, we've looked at this before. So I went straight from power of 10 to standard notation that we've seen. I skipped all the stuff in between. I skipped standard or expanded form. Now, I just out of random picked some number that I'm going to multiply by. So I decided, let's take these numbers and multiply by 4.5. It's just a random number. So if I take 1 times 4.5, I get 4.5. If I take 10 times 4.5, I get 45. 100 times 4.5 is 450. 1,000 times 4.5, and you see the pattern here. My numbers are getting bigger and bigger and bigger and bigger. Okay, let's take 4.5 and multiply by 0.1. I get 0.45. If I take 4.5 and multiply by 0.01, I get 0.045. And you can see what's happening. My numbers are getting smaller and smaller and smaller. And what's going to happen if they continue to get smaller and smaller and smaller in my calculator? I'm going to run out of display registers to actually put the number in, and all you're going to see is zeros. So the calculator is going to have to switch to another form. And the same thing happens with these large numbers down here. You're going to run out of display registers. You're not going to be able to show the whole number. Your calculator is going to convert super big numbers and super small numbers to scientific notation, which is this over here. Didn't I take 1 and multiply by 4.5? That's the same as 4.5 times this power of 10. Didn't I take 4.5 and multiply by 10? Well, that's 4.5 times this power of 10. Here I took 4.5 and multiplied by 100. Well, 100 is 10 to the second power. And what I'm doing here is I'm changing all of these answers over here to what's called scientific notation. Remember, A times 10 raised to some power? Well, here I've got 4.5 times 10 to some power. 4.5 times 10 to the negative 4th power gives you this. And this is small enough, you could actually do this in your calculator. And I do want you to do that. Grab your calculator, take 4.5 times 10 raised to the negative 4th power, and hit enter, it should give you this number. We have enough display registers to show this number. The thing I want you to notice about your scientific notation here is this factor out front, that A. This number has to be 1, greater than 1, but at the same time less than 10. That's just the rule. And 4.5 is between 1 and 10, so it fits the rule. Okay, take a look at this. In standard notation, we've got a decimal. So if I'm going to convert that to scientific notation, I know that the exponent on my power of 10 had better be negative because I've got a decimal number here. My exponent has to be negative. Take a look at the one down in purple. This is a large number. So if I have a large number and I'm converting it to scientific notation, my exponent better be positive because positive exponents create large numbers. Negative exponents create small numbers. What do the two numbers that are written in scientific notation have in common? Yeah, what do they have in common? Yeah, that factor of 4.5 out front times some power of 10. All right, definition of scientific notation. A number is expressed in scientific notation when it's in this form. A times 10 raised to some power. I think before it was R, here they're using N. Where the factor out front, the A, is greater than or equal to 1, but at the same time less than 10. And N is an integer, -3, -2, -1, 0, 1, 2, 3. Or bigger, or smaller. Vocabulary item number 18. When you write a number in the form A times 10 raised to the n power, where A is a number between 0 and 10, you are using scientific notation. Okay, converting from standard notation to scientific notation. I know we've seen this before. I'm going to show you the steps. The first thing I do, if I'm in standard notation and I'm trying to convert to scientific notation, the first thing I want to do is I want to look at the size of the number. And this number is a decimal. So since it's a small number, I know I need a negative exponent on my power of 10. There we go. That's the first thing I do. The second thing I do is this number A out front has to be between 1 and 10. So I need to pick up this decimal point and move it somewhere in the number so that I've got a number between 1 and 10. So I take the decimal and I move it between the 4 and the 5. That gives me 4.5, and 4.5 is between 1 and 10. The last thing I need is the number that goes on in my exponent, and all you have to do is count how many places you moved your decimal point. All right, let's see here. I went 1, 2, whoops, I clicked it. 1, 2, 3, 4. I moved it 4 decimal places, and that gave us our 4. That's how I convert this to this. And you know the biggest mistake people make when doing this is counting how many decimal places they moved that decimal point. That's the biggest mistake. Okay, take a look at this one. We're converting from standard notation to scientific notation. So here's the steps. I first look at the number, and it's a big number. So I know my exponent on my power of 10 needs to be positive. There we go. I just go ahead and put it in there. Now, the number out front, this A, has to be between 1 and 10. Well, in standard notation, where's my decimal point? I don't see one. It's right here behind the last zero. So I need to pick it up and move it into the number so that I create a number between 1 and 10. I'm going to put it between the 4 and the 5. My A is going to be 4.5. Now to figure out what the exponent number actually is, you just count how far you move that decimal point. It started off here and I moved it 1, 2, 3, 4, 5 places. And see how that number matches this number. Those are the steps to convert from standard notation to scientific notation. And we've talked about all of that here. You can pause the video and read this if you want to. Okay, so let's write each of the following numbers in scientific notation. First thing I do is I look at the size of the number, and this is a fairly large number. So I know the exponent on my power of 10 should be positive. I take the decimal point that's right here, and I move it so that my factor of A is between 1 and 10. Well, I'm going to place it here between the 4 and the 7. And now you just count how far you moved it. I moved it 3 places. So this becomes 4.7 times 10 to the positive 3 power. Positive because it's a large number, 3 because I moved the decimal point from here. 1, 2, 3. Take a look at part B. How do you convert that to scientific notation? Well, step 1. Is this a big or a small number? It's a small number. So should the exponent on my power of 10 be positive or negative? It should be negative. I need that factor of A that's out front in scientific notation. So I pick up my decimal point right here and I move it in the number so that it becomes a number between 1 and 10. I'm going to put it right here. That's 4.7. The negative exponent, the actual number part, is how far you moved your decimal point. Let's see, we moved it 1, 2, 3, 4 places. So this becomes 4.7 times 10 to the negative 4 power. Can you write each one of these numbers in scientific notation? Pause the video, give it a try. On part A, I have a large number, so my exponent on my power of 10 has to be positive. The factor of A out front has to be between 1 and 10, so I pick up the decimal point here after the last 0, and I move it between the 7 and the 8. That becomes 7.8. Now you count how far you moved it. 1, 2, 3, 4 places. I get 7.8 times 10 to the positive 4th power. You don't have to put the positive in there. All right, take a look at B. Step 1, do I have a large or small number? It's a small number, so the exponent on my power of 10 is negative. Now let's get that factor of A. Pick up your decimal point and move it where? Do I put it between the 6 and the 7? No, because 16.7 is not between 1 and 10. Do I put it between the 1 and the 6? Yes, because 1.76 is between 1 and 10. So it's 1.67 times 10 to the what? Well, you just count how far you move the decimal point. 1, 2, 3, 4, 5, 6. So I get 1.67 times 10 to the negative 6. We'll finish this up in one more section.